In this video, we are going to discuss about resource allocation graph. Resource allocation graph shows us how resources are allocated to various processes in the system. Also, this allows us to see whether there is a deadlock or possibility of a deadlock in the system. But before we go into the detail of resource allocation graph, let's see the component that you can see inside a resource allocation graph. We can see the vertices, and those vertices are one for processes in the system, and the other one are for resources. Circle identifies as processes, and rectangular boxes they're identified as resources. And as you can see inside these boxes we have dots. These dots mm, indicates the instances inside the resource. Some resource may have single instances and some resource may have multiple instances. So the number of boxes and number of dots inside the box would indicate how many instances that resource may have. And there are edges. Edges could be, one edge could be requesting edge and the other one could be assignment edge. Requesting edge are something like this. If you look carefully, you would see that one edge is going from process to resource. This suggests that process Pi is requesting a resource Rj. Similarly, in this diagram, one edge is going from resource to process, which means Rj is assigned to process Pi. Now, these are the components that you can see inside a resource allocation graph. Now, as we have said that we could figure out the deadlock or possibility of a deadlock by resource allocation graph. How we can do that? If we can figure out a cycle inside a resource allocation graph, then we can say there may be a deadlock. Remember that having a cycle is not the only condition of having a deadlock, but for having a deadlock, there has to be a cycle inside the resource allocation graph. But there might be cycle, but still there may not be deadlock. We'll see that in these two examples. The first one, see how it works. There we have three processes, P1, P2 and P3, and we have resources R1, R2 and R3. So if we like explain the edges between these resources and processes, one edge from P1 to R1, one from R1 to P2, one from P2 to R2, from R2 to P3, P3 to R3 and R3 to P1. This suggests that P1 requesting resource R1, R1 is assigned to P2, P2 is requesting R2, R2 is assigned to P3, P3 is requesting R3, R3 is assigned to P1. If we look here, P1 requesting R1, R1 is assigned to P2, P2 is requesting R2 and so on. So you can see that we started with P1 and we are ending with P1. See, in this case, what is happening is all the processes have acquired a resource, or should I say instance of a resource, even though all those resources they have only one instance. So they have acquired a instance or a resource, but they are not releasing any resource. At the same time, they are requesting a new resource, but the problem is, since they are not releasing any resource, no other process is getting any new resource, which means no one is releasing anything, at the same time no one is getting anything, which means the whole system is in a deadlock situation. Now, coming back to this diagram, we have processes P1, P2 and P3, and we have resources R1, R2 and R3. The difference between this diagram and this diagram is that resource R1 in this case has only one instance, but in this case R1 has two instances. Now see the assignment. P1 requesting R1, R1 assigned to P2, P2 requesting R2, R2 assigned to P3, P3 requesting R3, R3 assigned to P1, as well as, since there are two instances in R3, so R3 is assigned to P4. I have given a cross. Why? I'll explain. Now see, P1 requesting R1, R1 requesting R1 assigned to P2, P2 requesting R2, R2 assigned to P3, and so on. So we started with P1 and we are ending with P1. So as you can see clearly, there is a cycle, but still we are saying that there is no deadlock. Why? See, R2 has two instances. One instance is assigned to P1 and the other one is assigned to P4. If you look carefully, then you would see that P4 is not requesting any new resources from R1 or R2, which means if P1 is done with the instance that it is acquired or it is working with, it will release the resource. That's why I have given this cross. When it releases the resource, that means P3 can have that instance and the entire system, the requirement of all the process will be satisfied, which means the system will not be in a deadlock scenario. That's why we say that in this diagram, system is in a deadlock state, but in this diagram, the system is not in a deadlock state. In the next video, I'll explain with a practical example how resource allocation graph works and how scenario might change just by changing the requirement from processes. Thank you.